Welcome to the video on compound locus. First thing we're going to do is talk about what a compound locus is. A compound locus is a set of points, just like a regular locus is a set of points. But whereas a regular locus is a set of points that satisfies one condition or one criteria, a compound locus is going to be a set of points that satisfies more than one condition. So it might be 2 conditions or 3 conditions or 8 conditions. Most of the compound loci that we're going to examine in here this year are going to satisfy exactly 2 conditions. But again, it's just a set of points that satisfies more than one condition. All right, so the procedure that you're going to use to identify a compound locus is first of all draw the locus or the set of points that satisfies the first condition. Secondly, you're going to sketch the locus that satisfies the second condition. And then lastly, you're going to locate the point or the points where the two intersect, and those are going to be the points that satisfy both criteria. So I think of this kind of like solving a system of equations where you're going to graph both on the same set of axes and find the ones that they have in common. That's going to be exactly what you're going to do. You're going to sketch them both and then find the point or points that they have in common. All right, so in looking at the first example, it wants to know what is the number of points that's both 2 units away from line M and at the same time 3 units away from point A, which is on line M. So in looking at this, my first given here, or my starting place, is going to be line M. So I'm going to sketch on my graph anywhere that I want to a line that I'm going to call line M. And the first condition that we need to satisfy is we need the points that are 2 units away from line M. So that's the first condition that needs to be satisfied. Anybody who's 2 units away from line M. So I'm going to go ahead and sketch the locus of points that's 2 units away from line M. So these guys that are 2 units to the right of my line M are all 2 units away. There's also a set of points over here that are 2 units to the left of line M, and they're 2 units away from line M. So there's my first locus. My second condition is that I have to go ahead and have points that are 3 units away from point A, which is on line M. So there's my starting point for the second locus. I need to have some point A that's on line M. It doesn't say where that point is, so I can go ahead and put that point anywhere. And the condition that we need to satisfy for this second unit locus is that I need the set of points that are going to be 3 units away from point M. So I'm going to go find the group of points that are 3 units away from this point A. And that's going to be a circle around point A with a radius of 3. And the question here is asking me what is the number of points that satisfy both those criteria. So what is the number of points that is both on my red dotted locus and at the same time on my blue dotted locus? Well, if I take a look here, I've got 1 point, 2 points, 3 points, 4 points that are in both loci. Those are going to be the points that satisfy both criteria or both conditions. So 4 points. Now I use graph paper, and I really like graph paper, especially for sketching compound loci, because it gives me a frame of reference, it gives me a number of units that I can count. But we could have done this question the same as if we didn't have graph paper. I think the graph paper just gives us something to be a little bit more concrete with. All right, the next one says we're given 2 points A and B that are 6 units apart. So that's kind of my starting point, or that's where I'm going to work from. So I'm going to go to my graph paper, and on my graph paper I'm going to draw 2 points A and B which are 6 units apart. It wants to know how many points are there that are equidistant from both A and B. So without reading the second part of this problem, I know already that my first locus is going to be the set of points that's equidistant from points A and B. So I'm going to go ahead and sketch that locus first. So there's a point that's equidistant, there's a point, there's a point, there's a point. And again, I'm just going to begin or start sketching points until I get a feel for what the general shape of this locus is going to look like. So that red dotted line represents my set of points that are equidistant from both points A and B. The second criteria that needs to be met here is we also need the points to be 5 inches away from point A. So now I'm going to go ahead and I'm going to sketch the set of points that's 5 inches, or in this case 5 units away from point A. So there's a point that's 5 units away from point A. Up here's a point that's 5 units away from point A. Down here's a point that's 5 units away from point A. Somewhere out there's going to be a point that's 5 units away from point A. And now my locus is starting to take shape. I can see now that this guy's going to be a circle with a radius of 5, and point A is the center. So as far as points that satisfy both, there's one right there that's on both the red locus and the blue locus, and there's one right there that's on the red locus and the blue locus. So as far as numbers of points, there are exactly 2 points that satisfy both of the criteria. All right, number 3 says lines M and N are parallel and 10 units apart. So there's my given. There's what I'm given to work with at the very beginning. So I'm going to go ahead and sketch those lines M and N that are 10 units apart. So there's line M, and line N has to be 10 units from there. The other thing or criteria that needs to be met is A has to be at any point on line M. So I'm going to put A right there in the center, but you can put it anywhere you want as long as it's on line M. All right, the first criteria that we're trying to meet here, we need points that are equidistant from lines M and N. So the set of points that's equidistant from lines M and N is going to be the set of points that goes right up the middle, 5 units away from each. The other criteria that needs to be satisfied is we have to have points that are 7 units away from point A. So I'm going to go and locate some that are 7 units away from point A. There's going to be one somewhere up here off the screen, but that's going to be a circle around point A with a radius of 7. So as far as both points that satisfy both conditions, there's one right there that's on both the green locus and the red locus, and there's one right there that's on both the green locus and the red locus. So to answer the question, how many points are there? There are 2. All right, next one, similar. It says 2 lines S and T intersect at point A. So that's my given. That's what I'm starting with. I'm going to go ahead and sketch those lines S and T. And again, I choose to work on graph paper because it gives me boxes that I count and units that I can use. But you could draw this right on regular old paper too and get the same exact result. The first criteria that we need to, they intersect at point A. I guess I should label that, and I should also label line T. The first criteria that we need to meet, we need these points to be 2 units away from point A. So 2 units away from point A is going to be a circle around point excuse me, circle around point A with a radius of 2. And at the same time, equidistant from lines S and T. So if I think about points that are equidistant, 3 units to S, 3 units to T. And then we're going to have some lines going in these directions as well. So to answer the question, how many points are there that satisfy both those criteria? Well, we're looking for points that are both on the purple locus and the red locus. And to answer the question, there are exactly 4 of them. All right, next page talks about Steve and his treasure map. So it shows these trees that are exactly 8 feet apart. There's a fence that connects the 2 trees. And on the treasure map, it states that the treasure is buried 3 feet away from the fence and equidistant from the 2 trees. Now, after years and years of teaching this, what I found most effective is to use what I would call on Google Earth or Google Maps, I would call it the aerial view. Instead of looking straight ahead at these trees like we are in the picture, I want to think about being up above the trees and looking down on the trees. So this might be my first tree right here. This might be my second tree right here. And the fence is going to connect those 2 trees. The distance between the 2 trees is going to be 8 feet. But again, I'm going to use this aerial view as opposed to using this view that was given to me because I think it's more effective and simpler for kids to use. All right, so the first thing they want us to do is they want us to sketch a diagram to show all of the places where this treasure could possibly be buried. Clearly indicate in your diagram where the treasure could be buried. So our treasure needs to meet 2 criteria. It needs to be buried 3 feet from the fence. So if this is my fence, 3 feet from the fence might be 3 feet on this side of the fence and 3 feet on that side of the fence. And at the same time, the second criteria that needs to be met is this treasure needs to be equidistant from the 2 trees. So there's a point there that's equidistant, a point there that's equidistant, all these guys going up and down. This blue dotted line would be points that are equidistant from those 2 trees. So it said mark clearly. I'm going to put a little X there, and I'm going to indicate on my picture, X marks the spot. And I'm going to say for the treasure. All right, and then the second part of this question wants us to determine I believe how far it is from the tree to the treasure. So they want us to find this distance in here. Well, if this distance here is 3, and it is because this red dotted line is 3 units away from the fence, and this distance here is 4 feet, and it has to be because the total distance between the 2 trees is 8 feet, and this has got to be equidistant, then I know that the distance from the tree to the treasure has to be 5 feet in order to make a 3, 4, 5 right triangle. All right, the next question too has to do with a treasure map. It says there's a treasure hidden in a park near a tree and a statue. The tree and the statue are 10 feet apart. The treasure is going to be buried 10 feet from the base of the tree, and at the same time also 5 feet away from the base of the statue. They want to know how many places are possible for the treasure to be buried. Draw a diagram of the treasure map and indicate with an X each possible location of the treasure. So again, I'm going to think about this and doing this in the aerial view. So here's my tree, here's my statue, and it tells me that the distance between these 2 guys is exactly 10 feet. The first criteria that needs to be satisfied is that this treasure needs to be buried 7 feet away from the base of the tree. So 7 feet away from the base of the tree is going to be a circle around the tree, with a radius of 7. And that's going to go just over halfway to the statue. The second criteria that needs to be met is that this treasure needs to be exactly 5 feet away from the base of the statue. Well, if this guy was 7 feet and this guy has to be 5 feet away from the statue, these two guys are just going to barely overlap. So the blue dotted locus represents the second set of conditions. They want us to now mark with an X possible places for the treasure to be buried. So right there and right there. All right, and then the last question for this video, it says in the diagram below, town C lies on straight road, which is represented by line P. Sketch the points that are 6 miles away from town C. So I guess I can go ahead and start that without even looking at the rest. That's the first criteria that needs to be met. 6 miles away from town C is going to be the radius with a circle of 6, and town C is its center. The other criteria that needs to be satisfied in this problem is we need our locus of points to be 3 miles away from point P, or road P, I'm sorry, which is a straight line. Well, if this radius is 6, this guy or this locus is going to be about halfway to the edge of that circle. So anybody on that blue dotted line is exactly 3 miles away from straight road P. Likewise, anybody on this blue dotted line is going to be exactly 3 miles away from straight road P. So as far as points that satisfy both conditions, well, we've got one here, one here, one here, and one here. So in total, there are exactly 4 points that meet both sets of criteria. All right, so that'll do it for us for compound locus. If you have questions or I said things in the video that don't quite make sense or feel natural to you, please make a note of it now so that you can remember to ask me the next time that you come to class.